Hello everyone, welcome to another problem session. Today we're going to talk about this problem. The problem is in the free fall, one-dimensional free fall. One-dimensional free fall, one-dimensional. Okay, so always when you're reading a problem, you should look at the problem and and draw it out. Sketching is always helpful. Somehow our brains work that way. When you're sketching, you're kind of trying to make sense out of it. You're trying to clarify what the questions are, what's given. So here, as I read, it says we should draw a picture like this. Somewhere here, the ball is shot up and it's going to go up and then come down, and it's going to get caught over here. So somewhere here, this is, let's call it a starting place O, and there's a point B an instant before B, because after when you catch the ball, there's more force on the ball, and we want to have just an instant before it gets caught. Up to that point, it will be under gravity only. I'm going to call over here the same height. It was going up, but that's not in the question, but that could be a question that also. So this is the whole motion, and although I've drawn this picture like that, it's all happening on one axis. So O, and this is the ball caught at this height is B. We don't care about this whole thing. A lot of students do this problem by solving this whole trajectory. You just need initial and the final situation. So in initial situation, you have a 25 meter per second. So the V0 is 25 meter per second. We always, the axis always, we draw the positive side of the axis, say this is y-axis, and the initial velocity is in the same direction. That's convenient drawing. Over here, at the final, it's coming down, but we don't know this velocity. Over here, the time, we take it to be 0. Over here, t final is some time t, we don't know the value of it. So this is not known and this is not known. Yi is, by design, we've taken to be initial at origin. So this y final is, say this height is h, which is 10 meter given. So these are things about initial, and these are things about final, and in between, like this whole thing, that's the in between. We have a constant acceleration. And acceleration here is actually pointed down. Acceleration is pointed down. And its value, because this is one axis, and the direction we take into account by putting a negative sign, g, which was been told 10 meter per second square. I know it's 9.81 meter per second square, but we're going to just we're gonna use that value. So so acceleration in the entire thing is just constant this. Sometimes people write this with much more notation. We're not going to use it. Just to illustrate the notation will be y0 vy. This will be like ay. I'm just going to use letter a for it, but this will be the component notation. Okay, so let me I'm going to solve this problem now by reminding you the equations that you probably know is y minus y0 equals v0 t plus half at squared with a equals to minus g here, and v squared equals to v0 squared plus 2a y minus y0 and a equals minus g here, and v equals to v0 plus at with a equals to minus g here. There's another equation you can write. Y minus y0 is v plus v0 over 2 times t. Okay, so this is not known and this is not known. So if I go in these equations, it's very clear what to do actually. This is known, this is known, this is known, this is known. So only t is not known. So we can try to solve it. And it's going to be 10 equals to 25t minus half of 10 is 5t square. So you can divide by 5 throughout. You have t square minus 5t plus 2 equal to 0. This quadratic, there will be two answers. 1 over 2, 5 plus minus the square root of 5 square. 25 minus 4 times 1 times 2 is 8. So this is 5 over 2 plus or minus the square root of 17 over 2. I got two answers. We got T1 is 5 over 2 minus square root 17 over 2, and T2 is 5 over 2 plus square root of 17 over 2. And you can see when it was going up, that's T1 at this height. When it's coming down, that's T2 at the same height. So this is the answer we want. We want coming down. So this is when going up. Question may have asked that, then that would have been answer. So that's the answer for A. How about what is the velocity of the ball? So this is the next question, right? At the instant before it was caught. Of course, when you caught, after getting caught is 0. And many people confuse that. This question is asked is just before it hit your hand. So going with that, we can try to do B. You can see I already got the maybe this is the easiest one. Maybe this is the easiest one. So using that, I can get V equals to 25 minus 10 times 5 over 2 plus square 17 over 2. So this is 25 minus 5 plus the square root of 17. And it's going to be minus 5 the square root of 17 meter. Now this is minus, and that corresponds with the velocity being down That's v is down, so the vy is negative. So this is correct sign. If I got positive, I would be worried. Now let's do what was his speed going up at this time. When it was going up, it will be this time, right? So if you work that out, say c up, v for up, when it's going up, the v will be still same thing. V0 will be 25 minus 10, 5 over 2 minus the square root of 17 over 2. And so this will be 5 square root of 17 meter per second. This will be plus. So when it's going up, it's plus because it's in the same direction as the y-axis, positive y-axis. When it's coming down, it's the direction of the velocity is the opposite to the direction of the y-axis. So we expect negative, and so that is the b. Okay, I'm going to stop here. I'll see you in another video. Yep, bye.